The goal of this video is to explore some of the concepts or formulas you might see in a traditional physics class, but even more importantly, to see that they're really just common sense ideas. So let's just start with a simple example. Let's say that, and for the sake of this video, just so I don't have to keep saying this is the magnitude of the velocity, this is the direction of the velocity, etc., let's just assume that if I have a positive number, that it means, for example, if I have a positive velocity, it means that I am going to the right. And let's say if I have a negative number, which we won't see in this video, let's assume that I'm going to the left. And that way I can just write a number down. We're only operating in one dimension. You know that it's specifying both the magnitude and the direction. If I say that the velocity is 5 meters per second, that means 5 meters per second to the right. If I say it's negative 5 meters per second, that means it's 5 meters per second to the left. Now let's just say, just for simplicity, let's just say that we start with an initial velocity. We start with an initial velocity of 5 meters per second. And once again, I am specifying both the magnitude and the direction because of this convention here. We know it is to the right. And let's say that we have a constant acceleration. We have a constant acceleration at play of 2 meters per second, or 2 meters per second squared. And once again, since this is positive, it is to the right. And let's say that we do this for a duration. So my change in time is, let's say we do this for a duration of 4, I'll use the same 4, I'll just use s. So I don't use seconds and then sec and then s different places. So s for this video is seconds. So what I want to do is think about how far do we travel? And well, there's two things. How fast are we going after 4 seconds, and how far have we traveled over the course of those 4 seconds? So let's draw ourselves a little bit of a diagram here. So this is my velocity axis, and this over here is my time axis. I can draw a straighter line than that. So that is my time axis. Time, this is velocity. I think it's clipping off the left hand. That is my velocity right over there. And I'm starting off at 5 meters per second. So this is 5 meters per second right over here. So VI is equal to 5 meters per second. And then every second that goes by, I'm going 2 meters per second faster, because this is 2 meters per second per second. So every second that goes by, so after 1 second, I'm going to go 2 meters per second faster. So I'll be at 7. Or another way to think about it is the slope of this velocity line is my constant acceleration, or I have a constant slope here. So it might look something like that. So what has happened after 4 seconds? So 1, 2, 3, 4. So this is my delta t. So my final velocity is going to be right over there. So my final velocity is going to be right over there. I'll write it down here just because it's getting in the way of this word velocity. And so this is v. This is my final velocity. And what would it be? Well, I'm starting at 5 meters per second. So I'm going to do it both using the variables and using the concrete numbers. So I'm starting at some initial velocity. The subscript I says I for initial. And then each second that goes by, I'm getting this much faster. So if I want to see how much faster have I gone, I multiply the number of seconds. I'll just multiply the number of seconds that go by times my acceleration. Times my acceleration. And once again, this right here, I just wrote the subscript c saying that it's a constant acceleration. And so that will tell me how fast I've gone. If I start at this point and I multiply the duration times my slope, I will get this high. I will get to my final velocity. And just to make it clear with the numbers, these numbers really could be anything. I'm just picking these to make it concrete in your mind. You have 5 meters per second plus 4 seconds plus, I'm going to do that in yellow, plus 4 seconds times our acceleration of 2 meters per second squared. 2 meters per second squared. And what is this going to be equal to? You have a seconds canceling out with one of the seconds down here. You have 4 times, so let me write it. So we have 5 meters per second plus 4 times 2 is 8. 8. This second's gone. We're just left with meters per second. 8 meters per second. Or this is the same thing as 13 meters per second, which is going to be our final velocity. And I want to take a pause here, and you can pause and think about it yourself. This hopefully should be intuitive. We were starting at going 5 meters per second. every second that goes by, we're going to go 2 meters per second faster. So after 1 second, we'll be at 7 meters per second. After 2 seconds, we will be at 9 meters per second. After 3 seconds, we will be at 11 meters per second. And then after 4 seconds, we will be at 13 meters per second. So you multiply how much time passed times acceleration. This is how much faster we're going to be going. If we were already going 5 meters per second, 5 plus how much faster? 13 meters per second. So this right up here is 13 meters per second. So I'll take a little pause here. Hopefully that's intuitive. And the whole point of that is to show you that this formula that you'll often see in many physics books, it's not just something that randomly popped out of the air. It just makes complete common sense. Now, the next thing I want to talk about is what is the total distance that we would have traveled. Now, we know from the last video that distance is just the area under this curve right over here. So it's just the area. It's the area under this curve. You say, wait, this is kind of a strange shape right here. How do I calculate its area? And we can just use a little simple geometry to break it down into two different areas that are very easy to calculate their areas, or two simple shapes. You could break it down into this blue part, this rectangle right over here. Easy to figure out the area of a rectangle. And we could break it down into this purple part, this triangle right here. Easy to figure out the area of a triangle. And that will be the total distance we travel. And even this will hopefully make some intuition. Because this blue area is how far would we have traveled if we were not accelerating? If we just went 5 meters per second for 4 seconds. So if you go 5 meters per second times, so this is 1 second, 2 second, 3 second, 4 second. So you're going from time 0 to time 4. Your change in time is 4 seconds. So if you go 5 meters per second for 4 seconds, you're going to go 20 meters. This right here is 20 meters. That is the area of this right here, 5 times 4. This I guess purple or magenta area tells you how further than this are you going because you're accelerating, because you kept going faster and faster and faster. And it's pretty easy to calculate this area. The base here is still 5, because that's 5 seconds have gone by. And what's the height here? The height here is my final velocity minus my initial velocity. Minus my initial velocity. Or it's the change in velocity due to the acceleration. And the change in velocity due to the acceleration, 13 minus 5 is 8. Or it's this 8 right over here. It is 8 meters per second. So this height right over here is 8 meters per second. The base right over here is 4 seconds. That's the time that passed. So what's the area of this triangle? Well, area of a triangle is 1/2 times the base, which is 4 seconds. 4 seconds times the height, which is 8 meters per second, times 8 meters per second. Seconds cancel out. 1/2 times 4 is 2, times 8 is equal to 16 meters. So the total distance we traveled is 20 plus 16 is 36 meters. That is the total, or I could say the total displacement. And once again, it's to the right since it is positive. So this is our displacement. Now, what I want to do is do this exact same calculation, but keep it in variable form. And that'll give another formula that many people often memorize. But I want you to understand that it's a completely intuitive formula. And it just comes out of the kind of the logical flow of reasoning that we went through this video. What is the area? Once again, if we use it if we just think about the variables, well, the area of this rectangle right here is our initial velocity times our change in time times our change in time. So that's the blue. This is the blue rectangle right over here. And then plus, what do we have to do? We have the change in time. Once again, we have the change in time times this height, which is our final velocity, which is times our final velocity minus our initial velocity. Minus our initial velocity. These are all vectors. Oh, they're just positive, telling us we're going to the right. And if we just don't multiply the base times the height, that would give us the area of this entire rectangle. We have to take it by half, because the triangle is only half of that rectangle. So times 1/2. So times 1/2. And so this is the area. This is the purple area. That's not purple. This is the purple area right over here. This is the area of this. This is the area of that. And let's simplify this a little bit. Let's factor out a delta t. So if you factor out a delta t, you get delta t times a bunch of stuff, v sub I. So your initial velocity, we factored this out, plus this stuff, plus this thing right over here. And we can distribute the 1/2. We factored the 1/2. We factored the delta t's out. That's why we're taking it out. And let's multiply the 1/2 times each of these things. So it's going to be plus 1/2 times vf times our final velocity. That's not the right color. Let me actually do it in the right color so that you understand what I'm doing. So this is the 1/2. So plus 1/2 times our final velocity, minus 1/2 times our initial velocity, minus 1/2 times our initial. I want to do that in blue. Sorry, I'm having trouble changing colors today. Minus 1/2 times our initial velocity, times our initial velocity. And now what does this simplify to? We have something plus 1/2 times something else, minus 1/2 times that original something. So what is vi minus 1/2 times vi? So anything minus half of it is you're just going to have a positive half left. So these two terms, this term and this term, will simplify to 1/2 vi, 1/2 the initial velocity, plus 1/2 times the final velocity, plus 1/2 times the final velocity. And all of that is being multiplied by our change in time, or the time that has gone by. And this tells us the distance that we traveled. Or another way to think about it, let's factor out this 1/2. You get distance is equal to change in time times, factoring out the 1/2, vi plus vf. No, that's not the right color. Vi plus vf. So this is interesting. The distance we traveled is equal to 1/2 of the initial velocity plus the final velocity. So this is really, if you just took this quantity right over here, is just the arithmetic. I always have trouble saying that word. It's the arithmetic mean of these two numbers. And so I'm going to define this as something new. I'm going to call this the average velocity. But we have to be very careful with this. This right here is the average velocity. But the only reason why I can just take the starting velocity and the ending velocity and adding them together and then divide by 2, essentially taking the average of these two things, which would be someplace over here, and I take that as the average velocity, is because my acceleration is constant, which is usually an assumption in most introductory physics classes, but it's not always the assumption. But if you do have a constant acceleration like this, you can assume that the average velocity is going to be the average of the initial velocity and the final velocity. If this was a curve, if the acceleration was changing, you could not do that. But what's useful about this is if you want to figure out the distance that was traveled, you just need to know the initial velocity and the final velocity, average the two, and then multiply that times the time that goes by. So in this situation, our final velocity is 13 meters per second. Our initial velocity was 5 meters per second. So you have 13 plus 5 is equal to 18. You divide that by 2. Your average velocity is 9 meters per second if you take the average of 13 and 5. And then 9 meters per second times 4 seconds gives you 36 meters. So hopefully that doesn't confuse you. I just want to show you where some of these things that you'll see in your physics class, some of these formulas, why you shouldn't memorize them, and they can all be deduced.